Okay, so now we are ready to write programs. Well, so far we wrote programs which are one statement or two statement, but now we can really make program units. So program consists of three kinds of structures. So it's a class. Basically, every program will have it's a combination of structures which I'm going to tell you. So one structure could be simple sequential statements. So just set of statements one after the other. Second is branching or conditional statements. So if-then condition, so that is possible in all languages. And third is repetitive. So we have for loop or while loop, that kind of stuff. So let's look at the simple sequential statements. Is trivial, but I'll just give an example. I'm typing in IPython, so you can see this here. So x equal to 50, y equal to 100, and print x comma y. So the text box it just starts from here and goes here. So here there are three statements. They come one after the other, and they're executed line 1, line 2, line 3. So that's why it's called sequential and simple statements. There's no branching or repetition. These are simple statements. It's trivial. So anyway, it will be a program will contain these kind of blocks of codes. Branching statement. So you need this condition, like if something, then do something. If not, do something else. So it happens all the time in our life as well. So if something happens, then you do something. So there are several types of if these conditional statements in Python. In all languages, in fact. So, but you just have to worry about how it is implemented in Python. So I have variable x, which is value x equal to 3. So by the way, I say variable x equal to 3. So I say x is 3. I'm not saying that x points to object 3. So it's just too long a statement to make, which I discussed in the previous slides. So I'll say x equal to 3. Okay, so that's a simple way to state it. This complex stuff. So now we have if x modulo 2 equal to 1. Print x equal to x is odd. Okay. So what is this? When I divide x by 2, what is remainder? Okay, that gives you given by modulo function. It's integer division. And equal to, this is not assignment equal to. It is it's a checking whether is equal to 1. So double equal to means I'm testing. So this is a comparative statement. So I compare two objects, one in the left, one in the right. Are they equal? If equal, then it gives you value true. So true true is object true or false. Okay, so it depends on x. So if x is even, then I will get false. If x is odd, then I get true, and that's why I'm printing x is odd. So this statement is executed only if this condition is true. Okay, so otherwise this statement is not executed. It simply program will come here. So we can illustrate this in a flow diagram. This is called flow diagram. So x equal to 3. This is this one. So a square block is simple statements, and this is a conditional statement. So rhombus is a condition. Okay, so rhombus state condition. Now, so we have if this condition is true, then I go here. So yes or true, you can say. Then it comes to this code, and if it is not true, then it just goes out. It skips this block here. So the blocks after if will be executed if the condition is true. So this block is here. Now please keep in mind that there is some blank spaces here. So this is called indentation. So the indentation. So this is you indent, you shift. So this is critical. Otherwise, the program would not know what to execute after if. In fact, Python will just give an error if you don't indent after if. Okay. So this is critical thing, and code will break without it. It will simply give an error message and it will not execute. So Python indentation is critical. Without that, the code will not work. And you can choose any number of blanks. So I use normally 4. So 4 is not too many or not too less. And if I make another line here below, so that will be also executed if the if condition is true. So I could have more than one statement, but that again should have 4 blanks. It won't work if there are less than 4 blanks. Okay, or you choose. I mean, you want to use 3 blanks, is fine, but all the lines within a block must have same number of blanks. Now, one more point is the colon. So colon is also critical. So this condition is basically stopping here. So if you forget colon, then you will get an error message. The code won't work. And students make both the mistakes. They don't give proper indentation, or they miss this colon. Okay, so just be careful. And of course, you get an error, you fix it, but just make it a habit to write a correct code in the first shot itself. Now, this if statement, but we can have more complex thing called if else. So we can classify objects into numbers into even or odd. So if x is divisible by 2, then it is even. If not, then it is odd. Okay, so this else is doing that role. So if yes, if then else. Okay, so that is what I'm showing it here. So flow diagram is simple. So this is a conditional branch, conditional statement x modulo 2 equal to 1. If yes, do this. If not, do this. So this is code after else. Okay, and the colon after else as well. And this block belongs to else, and this block belongs to if. Now, in IPython, you can type this on the terminal itself, and you have to make sure that if and else are at the same level in terms of indentation, and this print is shifted. Okay. Now this is after the block. I mean, once I complete this stuff, I enter, it will come and it will execute. So by the way, interpreter is executing. So x equal to 2. It will just execute this block and give the answer x is 1. Of course, this one is going to give us odd because x is 3 here. Okay, so this if else. Now we can have another layer of condition. So if else, then within else there can be another if. So this is what I'm showing here. So example is if the number is odd. So if it is even, then you're done. If it is odd, then I want to see whether it's divisible by 3 or not. Okay. So this slightly complex structure. So we have x equal to 3. If it is divisible by 2, then say that it is even. If not, then come to this side. Then again do another test. So it is odd now, but I want to test. Is it divisible by 3? If it is, then I say x is divisible by 3. If not, then I have to say that x is indivisible. It's not divisible by both 2 and 3. Okay. So this is what is done here. So else if, elif is else if, is short form for else if. So put a colon again. So it first just checks this condition. If true, then comes here and gets out. If not, then comes here and tests here. If this is true, then it will print this and get out. If both the conditions are true, then it comes here and it prints this. Okay, so it's straightforward, but you have to, so this is syntax. Now let's do a simple example called leap year. So leap year is a slightly complex logic. Leap year, the February is 29 days. So, and this is because the Earth does not go around the sun in 365 days, it's 365 and a quarter, but there's a further correction than a quarter. So not every fourth year is a leap year. So here the logic is if year is divisible by 400, then it is a leap year. So for year 400, 800, 1200, 1600, they're all leap year. Though it is divisible by 4. Okay, so it's a leap year. Okay, so it's divisible by 4, of course it's a leap. But if it is divisible by 100, then it is not a leap year. So 1700 is not a leap year, or 2100 will not be a leap year. Okay. Otherwise, if year is divisible by 4, then it's a leap year. So there are slightly complicated logic here. So this one works. So first test, you keep filtering out. First, filter out all 400s and call that a leap year. If I divide by 4, then that will not be correct. No, I mean this logic, this one will not be picked up. So I created this in my code. So if year is divisible by 400, leap year. Else if year is divisible by 100, then not a leap year. Else if year is divisible by 4, then a leap year. Else is not a leap year. So there are two conditions for not a leap year, and there are two conditions for leap year. So 1984 is a leap year. Okay, so well, I didn't put the answer, but it's a leap year. Okay. Anyway, so this is about if statement. Many of you know programming, so you know this very well, but I had to cover it for Python. So I'm not covering all of it. So you have to look at notes, like for example, less than equal to is a condition. greater than equal to the condition. What is a Boolean variable? So true and false are Boolean variables. So read notes for further information. I want to shrink this programming part so that we can go to the numerical algorithms as soon as possible.